What? So this is Shadowfax. He's very unruly. He's really unruly. He's getting hair all over everything. Okay, Shadowfax. That was your moment in the sun. Look at the camera. He's actually completely messing with the tripod right now. Okay. Alright, we're done here. Okay, come on. Let's go. Let's go. Come on, let's go. Okay, so that was my cat, Shadowfax, messing around with the tripod. Did he like screw up the dimensions? I just have to check to see if everything here is in order. Looks like everything is okay. All right, so let's go to work. So this is the ratio test and strategy. So the ratio test and strategies. Roughly speaking, this is 11.6 and 11.7. Okay, and all of that shows up. Okay, good. So so you guys will remember what the ratio test says. So the ratio test is a test for convergence of a series. It says that if you have a series and you look at the following limit. Take a look at the limit as n goes to infinity of the n plus 1 term over the n term. You take the absolute value of this. Then if and so we have the following. Setup based on what the value of L is. So if L is less than 1, then this series converges absolutely. So converges absolutely. And if it's bigger than 1, then the series diverges. And if it's equal to 1, then this gives us no information. Okay. So this is the ratio test, and remember what it means to converge absolutely. That means that the series made up of the forms, when you take the absolute value of the terms and sum them up, that this converges. So, I mean, in particular, it means the series converges. So let's take a look at an example of this. We've seen several examples, but let's just do a very simple example. So starting at n equals 0, we'll do 1 over n factorial. So here, the an plus 1 term is just 1 over n plus 1 factorial, and the an term is 1 over n factorial. So if we took a look at so L is the limit as n goes to infinity of the absolute value of, it's the n plus 1 term divided by the n term. So here we have n plus 1 factorial divided by 1 over n factorial. So it's a factorial symbol right there. Okay. All of these terms are positive, and so the absolute values are not consequential in this calculation. So we get the limit as n goes to infinity of, so we do a little bit of algebraic judo, and n plus 1 factorial goes to the denominator, n factorial down here goes to the numerator. And so this is the limit as n goes to infinity of 1 over n plus 1. So we covered this in class. You have the product of the numbers 1 through n up here, and the product of the numbers 1 through n plus 1 up here. So what's left when you do the canceling is this, and this limit is 0. Okay, so L is less than 1 because it's equal to 0. Therefore, the series converges. It converges absolutely. Okay. So great. So that is one example of the ratio test in application. Let's do another example of the ratio test. How about this example here? I have cat hair. There's cat hair all over this. You can't see it on the paper, but it's there, and it's all over my hands. Shadowfax. I will destroy him later, just for shedding. I won't really. Don't report me to the animal abuse people. So how about this series right here? So let's try 10 raised to the nth power over oh, I don't know. Let's try something like this, n factorial, and we'll even make this a minus 1 to the n. So we get something like, well, anyway, so this is the series. So I just made this up off the top of my head, and we're going to check what happens. So the so check for convergence. All right. So if we take, we have L is the limit of the absolute value of the n plus first term over the n term. Okay. So if we take a look at what this is, all right. So we have a minus 1 that's going to occur in a lot of these terms, but we can always ignore the minus 1 when we take the absolute value. So this is really the limit as n goes to infinity of. So the n plus 1 term is 10 to the n plus 1 over n plus 1 factorial divided by, and then we have 10 to the n over n factorial. Okay, so again, no minus 1s. Okay, so right, the absolute value took care of that. And we do a little bit of algebra here. We have 10 to the n plus 1. Downstairs we have a 10 to the n. And then we get n factorial over n plus 1 factorial here. So these are just fractions being multiplied together. So if we simplify this a little bit, which we can and we must, there are n plus 1 tens on top and n tens down below, so that leaves 1 10 at the top. And then, just as in the last problem, we had this cancellation happen. Okay. So 1 over n plus 1 goes to 0, so this limit is 0. Okay. Again, it's less than 1, so this series converges absolutely. Therefore, the series converges absolutely. Okay. We went through a bunch of other examples in class, so I'm going to leave it there. But now I want to talk to you very briefly about strategy for testing a series for convergence or divergence. Okay, so this is just a very, very quick strategy session here. So suppose you have this series given to you. So the very first thing you should check is the series geometric? Okay, right. So that's just seeing is if you take the ratio of one term to the term that came before it, is this equal to some constant for all n? Okay. If that's true, then the series is geometric, and so we know how to determine the convergence or divergence of such a series already. Okay. If not, check whether or not the terms go to 0. Okay. If they don't, so if the terms don't go to 0, then the series diverges by the test for divergence. That was shadowfaxing. If you heard him, he wants more attention. Maybe in a little bit. If he keeps crying, I generally just cave when he cries, just like with my class. So anyway, so we've got, is it geometric? Okay, if not, then you move on. Check whether or not the terms go to zero. So if they don't go to zero, then the series diverges. All right, one sec. What? Come on. Because he's like an attention getter, we're just going to shove him back in the camera. So there he is again, crying, wanting attention, maybe wanting to do some calculus. Right now I'm just shaking him really badly because he loves it. I don't know. Anyway, so okay, we get up. My cats are restless today. You might have heard Sylvester crying in the background as well. Maybe they'll make an appearance in one of the later videos. Okay, so where were we? So the next step is to maybe ask yourself, is the series alternating? Okay, if it's alternating, then of course you can try the alternating series test. Okay, 4. Is an a ratio of polynomials or roots? So for example, maybe you're looking at something like the square root of n plus 2 over over 3n cubed plus n squared, something like this, just an example. So here, this series should act like the series square root of n over 3n cubed. Okay, and so you try the limit comparison test. Okay. 5, if you see the factorial symbol or exponents, so I guess maybe I should say and or exponents, then try the ratio test. Okay, so this is your general strategy for determining whether or not a series converges or diverges. The primary place you should be looking in here is the questions that I've assigned from section 11.7. Gives you an opportunity to practice some of these techniques, but this is generally the order that I think about in terms of when I see a series and I'm asked whether or not it converges or diverges. Great, so we'll continue on with power series in the next video.